Assalamu alaikum. Can you all hear me? You hear my voice? Okay. Is it clear? My voice is clear? Yes. So good. Okay. Okay, let's start. We're already behind about 5 minutes waiting for you. Okay. So, in this Monday, we talk about the first layer in the network modules, which is the physical layer. And we discuss in detail the two kind of signals that go through this layer, which is the analog signals and the digital signals. And we talked about the parameters for each one. The analog, the peak amplitude and the frequency. The last one is the phase, and we talked about the bandwidth for the analog signal as well. Then for digital, we talk about the bit rate and it was the bit length, I guess. Yeah, the bit length. Okay, a lot of physics. Anyways, today we're gonna continue talking about the physical layer. But we're going to discuss the transmission impairments. What make the signals weak? What affect the signals in negative way? Okay? So we're going to discuss 3 major causes for impairments: the attenuation and distortion and noise. We're going to know what is the cause of attenuation and how we can avoid it. And same as well for distortion and noise. Okay? So what is attenuation? As I mentioned, the wave in the signal, in the analog signal, or in the digital as well, it always carries some amount of energy, what we call the amplitude. So what's happening here is when the wave is attenuated, it starts losing some of this energy. Okay? Of course, when the signal loses some of the energy, it won't be the same when you receive the signal. It will be different. So if it carries some data, the data will be different in the final destination. What is the cause of the attenuation? Why this signal starts losing this energy, or in some situation it's the opposite. It might gain more energy. It's because of the medium that carry these signals. It could be by the cable is the reason. What's happening here is the cables or this medium start resisting the signal. Then it will produce some heat. Okay, this heat, okay, will cause for losing this energy. Sometimes if you touch the wire, okay, or the cable, you will find it warm. Okay, so this heat will make the signal lose energy, or in some situation gain energy. So in the final destination, it will be the same. Okay. واضح? Clear what is the reason or what is the cause of attenuation? I need a response. I need to feel that I'm not talking to myself. Is it clear? Okay. So what is the cause of attenuation? I see someone typing, so hopefully gonna give me the right answer. I think I'm scared you away. Okay. The cause of attenuation again is the resistance of the medium, the cable or wire or whatever is carrying these signals. Okay? Then the heat will be produced, and these heat will cause loss of energy or gaining energy. What is the solution? What we can do to avoid this problem? We could use something called amplifiers. What is amplifiers? Look at the diagram. It's a small or specific tool or device. We could use it. We could attach it to the wire as an input and output. Okay. So when the signal comes through this amplifier, it will be amplified. هيحصل لها نوعا ما تضخيم the signal. So if the signal is attenuated, that means it loses energy, and then it will be a little bit weak. So the amplifier will be responsible to amplify these signals. And as a final, it will be the same in the final destination. Okay? Let me show you a picture of this amplifier. It looks like this. So you're gonna put the wire from one side as an input, where the signal is input to this amplifier, and the other will be the output. So the input will be attenuated signal, and the output will be the same as the original signal. Okay? Are you familiar with this? Have you seen it before? Okay. So glad to be the first one to show you that thing. Okay. How can I measure the lose of the power or the energy or the gain of this power? الآن احنا قلنا إنه energy starts losing. إذا كانت الsignal attenuated, it will lose the energy. هتخسر شوية amplitude. Or in some situation قلنا إنه it might gain more energy. How I can measure these losing or gaining of power? There's something called decibel. Decibel. Decibel is the unit to measure these losing or gaining of power. There is a simple formula you're going to follow. It's 10 log 10, and the power after losing by the power before losing. Okay, or the original power. Let's see an example. Here is the formula. Look at the formula. You see the circle or whatever shape that I'm drawing. I'm going to use another color so it'll be more clear. Okay, see, this is the formula. P2 is the amount of power after the losing or gaining power, and P1 is the original power. طبعا ايش الباور اللي بتكلم عنها؟ اللي هي الانرجي. يعني الامبليتيود للsignal when was first submitted or transmitted, and P2 is after the signal has been attenuated بعد ما حصل لها losing energy or gaining energy. Okay, so let's see this example. It says suppose the signal travels through a transmission medium and its power is reduced to 1/2. This means that B2 will be half of B1. لأنه it's less by half. يعني الpower خسرت نص energy. Okay, lose a half of the energy. So B2 is gonna be half of B1. So in this case, the attenuation, the loss of power can be طبعا الفورمولا 10 log 10 P2 by P1. Then 10 log 10, it will be هنشيل P2 and we're gonna put half of P1. So if you do some mathematics here, you're gonna get rid of the P1. So it will be 10 log 10 multiplied by half will be 10 times minus 0.3. Then the result will be minus 3 dP, which is the cycle. Okay? So in this case, في هذا example, it was losing energy or gaining some energy. Oh, I'm not going to use energy, I'm going to say power. Can I lose power or gain power? بعد ما حصل السيجنال attenuated or attenuation. It was losing خسرت power or gain some power. زادت power لها. Lose, right. Here, in this situation, the attenuated signal lost some power. Okay? Let's see the second example. Signal travels through an amplifier. هنا حطينا amplifier, okay, to avoid these problems. And its power is increased 10 times. حصل increased the power. This means that P2 here is equal to 10 of P1. Okay? يعني هنا ال P2 اللي هي ال power after the attenuated, it was increased by 10, double 10, not double, sorry, 10 amount of the original power. In this case, the amplification is cause of gain of power, can be calculated as 10 log 10 B2 by P1, and then equal, you're gonna replace P2 by 10 P1, and then get rid of P1, it will be 10 log 10 times 10, so the result will be 10 cycles. Clear? Is there any question about the attenuation? واضح? The first environment. So what is this? Okay, I have a question, I think. Teacher, the rest of us cannot enter the class because the same problem as yesterday in a blackboard. I know. Okay. Anyway, I cannot help them, but the lecture is recorded, so if they join us, will be great. If they couldn't, then they can play the recording again. And by the way, I'm not responsible about the attendance of the virtual class. It's not my job to take the attendance of the virtual. There are some people in university working on that. They can enter the virtual class later and check whoever attend or not. So I hope they will understand that there is a problem with Blackboard. Me too. Okay. Alright, let's continue. Okay. Everything clear now about the attenuation? Any question? Before I move on to the second empowerment. Okay. A lot of math. You haven't seen anything yet. As I told you, math, if you're IT students, so math is going to be in your blood. You're going to face math in every aspect of the IT. We use math a lot, so do not complain about it. Okay. Okay. I'm not worried actually, I love math. The second impairment factor I'm going to talk about is distortion. Distortion, اللي هو تشويه. How the signal can, or actually is the shape of the signal going to be changed at the receiver. So, what is distortion and how it's happened? It's actually when the signal, as I told you, changes its form or shape. The cause of distortion mostly is the delay. The differences in delay will create a difference in the phase of the delay. It's not going to be exactly the same as the period duration. Okay? So it gives you a period of duration. This signal is supposed to arrive, like for example, in 2 seconds. but some delays has been happening here. This delay, the difference of these delay, it will cause difference in the phase. Do you remember with the phase we said the waveform and the position of time zero? So it causes difference in the phase. These differences will cause the distortion of the signal, of the shape of the signal. Okay? And this kind of distortion is only happen in composite signal. What is composite signal? Remind me, what is composite signal? What I mean when I say composite signal. What is composite signal? Come on, it was only Monday, 2 days. You forgot. Composite signal is the opposite of simple signal. And when I talk about composite signal, I'm talking only about analog signal. Open your note if you have fun. Okay. Oh, finally, someone typing. Scared away. Composite signal is a signal has multiple waves, multiple sine waves. Not only one. Simple signal is with one sine wave, and composite signal is a multiple sine waves. So the cause of distortion is the delay, as I told you. How are they going to solve that thing? They could use also some kind of amplifier. Amplifier could be used here too. And mostly you can use some kind, yes, and you can also use some compression. But the best way to avoid this problem is to use that Lay's telephone line. If you use this kind of line, شايفينه? You see it? Yes. Good. Different frequency because it's multiple waves, and each wave has its own frequency. Okay. So to avoid the distortion, you can use the Lay's line. There was a cable in front of you. Okay. واضح الدistortion? What is the cause of distortion and how can you avoid this distortion? Perfect. The third and final transmission impairment I'm going to talk about is noise. Okay? Noise has many types. There are many types of noise. We have the thermal noise, we have the induced noise, and we have the crosstalk, and we have the impulse noise, and yeah, that's it. All these types of noise can corrupt the signal. As you see in the picture here, do you see that? This is the transmit signal. And there were some noise in the way. See? And this is the received signal. It is totally different. Okay? Same thing happened in real life. Like when I'm talking to you and there is a lot of noise around me, you may not hear me clear, and you may hear another word because of the noise. So the noise could change the received signal. The form or the shape of the signal is totally different. Is it the same? Are they the same? The transmitted and the receivers? Yes, no. They totally different. Okay. So let me talk about each type of these noise. The thermal noise, usually when I say thermal noise, you should think about the heat. Okay. So what is caused this thermal noise? It's caused by the random motion of electrons. Do you know what is electrons? Electrons, protons, yeah. I think now we move to chemistry. Do you remember these things? The atom has electrons, the specific electrons and protons, and yeah, I forget all this stuff. Okay, so these electrons in the atom, usually they are in motion, in random motion all the time. They're not like stable, they're moving all the time. These random motion will cause a heat in the medium. Okay, so what happens here, it will create or produce an extra signal sent by transmitter. Do you believe that? So if there is a thermal noise in the way of the signal, it will create extra signal with the original one. So definitely at the end you will receive totally different signal. Okay, this is the first type. Usually this one is common in the satellite connection. Okay, the most common type of thermal noise in satellite connection. The second type, which is called the induced noise, this comes from sources such as motors and appliances. Like for example, if you have a motors, you know motors? Okay? It sits next to the medium. يعني كان موضوع جنب الكيبل for example. Okay? And the signal starts travel through this cable. Okay? These motors will work as just a second. Yeah. I'm lost. Yeah. Okay. These motors will work as transmitting or antenna. Okay. What I mean with a transmitting antenna or sending antenna. يعني حتبدأ هذه الموتور ترسل تصير زي الانتنا. You know the antenna? It will start sending some signal للكيبل للميديوم اللي انت بتستخدميه. والميديوم هو الكيبل حيصير في the receiving antenna. It will become as a receiving. It will act as a receiving antenna and start receiving these signals from the motor. طبعا when you start receiving a new signal from motor, this will cause a change on the original signal. واضح؟ واضح النوع الثاني؟ Okay. Third type of noise, which called is crosstalk. What is crosstalk? This is really simple. When you put a specific wire on top of other wire. يعني لما تحطي two wires above each other. تحطيهم فوق بعض. Okay? One wire is gonna act as a sending antenna and the other will act as receiving antenna. يعني الواير اللي فوق حيبدأ يرسل signal to the other wire, and the other wire, the wire at the bottom will receive these signals, and this source will cause to changing to the original signal. The last type of noise is the impulse. Yes, like clash between them. Yeah, like the signal will be mixed between these two wires. Impulse noise, the last type, it's caused by a spike. What is spike? Is sometimes the high energy in a short time. If you use a very power line, like the lightning, إذا كنت مثلا بترسلي إشارات ضوئية, these power lines sometimes will suffer from high energy in short time. These will cause a spike. Having a spike will be subject noise. Okay, and of course it will produce another signal or called change in the original signal. Okay, these are the four types of noise اللي هي thermal noise والinduced noise والcrosstalk والimpulse noise. Okay? في سؤال about them? Any question? Okay, good. If I'm talking about noise, there is a formula. It will allow me to measure the signal to noise ratio. الفورمولا هذه إيش؟ It will be the average of signal power by the average of noise power. هتقسمي the power of the signal, the average of the power of signal power على average of noise power عشان توجدي إيش؟ توجدي signal to noise ratio. Okay? So let's take this example. The power of a signal is 8 milliwatt. See this one? Okay? Now the power of a signal. And the power of noise is 1 milliwatt. What is the value of signal to noise ratio and signal to noise ratio disciple? So we have two values we asked to find out about it. Okay? To get the signal to noise ratio, we can use the formula that I told you, the average of the signal power على average of signal noise, or noise power, sorry. So when we have here the signal power, it's 10 milliwatts. If you convert it to milli watts, it will be 10,000 على 1 milliwatt. لازم توحدي الunit, and then here's the result. How I can find the signal to noise ratio? It's so simple. You're gonna use this formula. 10 log 10 to SNR. This is signal noise ratio. Okay? Where we get this signal noise ratio is right there. Okay? So 10 log 10, 10 power of 4 will be 40. Okay? واضح? How we can find out the signal to noise ratio and signal to noise ratio disciples. Any question about the noise? Any question? Any question about the attenuation and distortion and noise? Okay, good. Now I want to talk about something called data rate limit. Data rate limit is very important. Why? Because it finds out how speed or how fast the data can be sent. So when I'm asking what is the data rate limit, I'm going to ask you about the speed. Okay? About how fast the data could be sent. So to measure that, it'll be the unit we could use is bits per second. Okay? There is two theoretical formulas we can use here. اللي Nyquist we Shannon. The Nyquist usually used for what? You should keep that in your mind. This is very important. The Nyquist is only for noiseless channel. Okay? The channel does not affected by noise. Okay? And Shannon is only used for noisy channel. Why? Because if you're gonna find out how fast the data can be sent in noiseless channel, you don't have to care about the noise that could affect the signal. But if you want to talk about the channels that are affected by noise, you have to find out the signal to noise ratio. So this is the formula. We have bit rate 2 times bandwidth times log 2 L. L is the level. How many levels do you use? Do you remember the level? In digital signal, we have levels. 1, 2, 3. Yes. So here is how many levels. And for Shannon, the one that I use for noisy channel, is bandwidth times log 2, 1 plus SNR, which is signal to noise ratio. We just talked about it. واضح? Let's take an example. Consider noiseless channel. Okay, I'm telling you, we gotta find out the data rate limit for noiseless channel. So which theoretical I'm gonna use? Nyquist or Shannon? Nyquist or Shannon? Nyquist. Good. I have the bandwidth, 3000 hertz, transmitted a signal with 2 signal levels. The maximum bit rate can be calculated as this. Bit rate will be 2 times 3000, which is the bandwidth, times log 2. 2 is the number of levels. We have 2 levels, and here is the result, 6000 bits per second. So how fast is it? It's going to send 6000 bits in 1 second. Okay? Let's see another example. The signal to noise ratio is often given in decibels. Assume the signal to noise ratio decibels is 336. Okay, here it starts talking about noise. So which theoretical we should use? If we're talking about channels that are affected by noise, which theoretical I'm going to use? Nyquist or Shannon? Shannon or Nyquist? Yes, Shannon. So the Shannon bandwidth is 2 megahertz. The theoretical Shannon capacity can be calculated as well. Okay, let's check the formula. Checking the formula with Shannon, I have to find out the bandwidth. He already gave me the bandwidth, and I need to find the log 2 for 1 plus signal to noise ratio. But in the example here, he didn't give me the signal to noise ratio. He gave me the signal to noise ratio decibel. So I have to find the signal to noise ratio. As we discussed, signal to noise ratio decibel is 10 log 10 of signal to noise ratio. Right? Okay, just give me a second. Okay. So let's put a value. Signal to noise ratio will be, if you take the opposite, will be 10 the power of signal to noise ratio decibel by 10. Then it will be the result. If you do the calculation, it will be 10 power 3.6, and the final result will be 3,981. This is what? This is the signal to noise ratio. Now I have the signal to noise ratio, so it's easy to follow the formula for Shannon. The capacity will be B. B is the bandwidth, log 2 equal 1 plus signal to noise ratio will be 2 times 10 power 6, and then log times log 2, 3,982, and the result will be, do the calculations, 24 megabytes per second. Any question about this one? Do you have any question about the data rate limit, Nyquist and Shannon theoretical formula? Clear? Good. Okay. The last thing I'm going to talk about it regarding the physical layer is the performance. Okay? There are several factors that affect the performance of the physical layer: the bandwidth, the throughput, and latency and jitter. Okay. First of all, the bandwidth. I think we talked about the bandwidth, but here, let's say there are 2 types of bandwidth, because we are talking about 2 types of signal. We have the analog and we have the digital. So if I'm going to talk about analog, the bandwidth is going to be by hertz. If I'm going to talk about digital, it will be bits per second. Okay, so in bandwidth, the bandwidth in hertz, because I'm talking about analog, so it will be the range of frequencies in composite signal or a channel. But in bits per second or in digital signal, it will be the speed of bit transmission in a channel or a link. Okay? I think we talked about that bandwidth enough, so let's move on to the second factor, the throughput. What is the throughput? It measures how fast we can actually send data through a network. Okay? Usually, the bandwidth is same as the throughput. Let me tell you, the bandwidth is always larger or equal to the throughput, but it's never going to be less. Okay? خدي بالك إنه الباندويث okay, always larger or equal to the throughput. Why? Let's take this example. If there is a bridge, okay, this bridge can transmit 1,000 cars per minute. And in 1 minute, 1,000 cars can pass this bridge. Okay? So the bandwidth here will be what? 1,000 cars per minute. And the throughput will be also 1,000 cars per minute. Okay, because there is 1,000 cars pass this bridge in minutes. But let's assume we are on the rush hour. Okay? The bandwidth here will be also 1,000 cars per minute. Okay? But the throughput will be 100 cars per minute. It's reduced ليه؟ لأنه rush hour. يعني ببساطة الباندويث احنا بنتكلم عن الكاباسيتي، المساحة، مش المساحة، السعة. يعني البريدج هذا كم يستوعب أو كم يسمح العدد من السيارات إنها تمر في دقيقة واحدة. Okay. لكن الثروبوت is the what do we call it in Arabic? الإنتاج. Yeah. يعني إنتاج يعني it doesn't matter. صح إنه هذا البريدج بيستوعب 1,000 car. Yes, 1,000 car in 1 minute, but it was rush hour. كان في زحمة. فما قدر تمر إلا 100 car. Okay? في الدقيقة الواحدة. So دائما الباندويث it's always fixed. ما بيتغير. Okay? السعة دائما ثابتة ما راح تتغير. لكن الثروبوت it's changeable. It's depending on the situation. Okay? واضح الديفرنس between الباندويث and throughput. طبعا هذا عامل يؤثر على this is a factor will affect the performance of the physical layer. If there is it could happen rush hour, it could happen in cable. ممكن تحصل إنه يكون في زحمة على الكيبل. Okay. Third factor, latency. It's clear that is the delay. The delay of the data has been transmitted will affect the performance for sure. How long it will take for the entire message to arrive completely at the final destination will affect the performance for sure. يعني إذا تأخرت طبعا معناته إن performance will be less. هيقل البرفورمانس أو الكواليتي البرفورمانس هتقل. So how can I find the latency? There is a simple formula. We can find out the latency. It's the propagation time plus the transmission time plus the queuing time plus the processing delay. Okay, تقدري تحسبيها من هذه الفورمولا إنك تجمع propagation time plus the transmission time الوقت اللي أرسلت فيه المسج, then the queuing time اللي هو the time that the message been hold be processed. يعني زي وضعت في إيش؟ في line, waiting line to be processed. And the plus the processing delay. الوقت اللي تأخر على ما يحصل البروسيس لهذه الداتا. Okay? How we can find the propagation time? The propagation time we can find it by simply divide the distance by the propagation speed. And the transmission time, وقت الإرسال, how we can find it? By the dividing also the message size by the bandwidth. Okay? You will find all these formula in the slides. Okay, good. Last thing, jitter. Jitter is happening when different packets of data encounter different delays. And the application that's using this data at the receiver side is time sensitive. يعني إيش؟ يعني when a message we all decided that the message is will be divided as a bucket. هتتحط في bucket ممكن تتجزأ. So if each packet of this message encounter delay, حصل delay in each packet, that means we have multiple delay. Each يعني مو بس delay the entire message. No, each packet of this message will cause a delay. And when they all arrive to the final destination, they were an application. كان في application يحتاج إنه يقرأ هذه المسج, and this kind of application is time sensitive. هذا الapplication time sensitive زي الفيديو or audio data. يعني مثلا if I want to send the sound, زي لما أنا الآن بتكلم معكم. Okay, I'm talking now. You hear my voice. Okay. Sometimes a delay could happen to my voice. يعني أنا بتكلم الآن لكن أنت بيوصل لك الكلام after 2 seconds, for example. And I've noticed that يعني أنا لما بسأل سؤال sometimes I have to wait a little bit to get your response لأنه أنت لسه ما وصلك سؤالي. So this is the jitter. Okay, هذا اللي حصل إنه الjitter إنه my voice or my message. This is here my message is my sound. When it's recorded and it starts sampling this sound, هيتحط في باكيت. كل باكيت مثلا سبب delay. So when it arrives to you, it arrives late. Of course, it won't be that much problem if I'm talking to you right now. Like for example, if you're watching a movie, okay, and you watch a movie online, and the audio were transmitted delay. طبعا انت حتشوفي الصورة لكن الصوت حيكون متأخر. This kind of application is time sensitive. معناته انت ما تقدري توافقي ما بين الصوت والصورة because there were a jitter. واضحة الفكرة؟ طبعا to find the amount of the jitter you have to add the times of delay for each packet. يعني for example, if you have delay in packet number 1 for 20 minutes, then you have for the second packet 45 minutes, for example, and for third one, let's say 40 minutes. عشان تعرفي amount of delay, you can add 20 plus 45 plus 40, and the result will be then the real-time application that use the packet could induce the jitter. طبعا to solve this problem ممكن إنه نفس الابليكيشن يحسب time of delay وبعد كده يبدأ يتعامل معه أو يبدأ يخفف هذا الجرر. واضح؟ واضح ال 4 factors that affect the performance of the physical layer. في أي سؤال عليها؟ أكيد for sure. Okay, good. طبعا as I told you in the face-to-face lecture, troubleshooting tips, always look at the physical layer. دائما 80% of the issue in the network caused in the physical layer. فإذا كان عندك أي مشكلة go first check your cabling, your mediums, your physical layer too. So 80% the problem could be there. Okay? That's it for our lecture today. Good. We have 10 minutes left. أي سؤال؟ Ask me. في أي سؤال عن lecture today? And the assignments, if you look at the assignments from about the face-to-face lecture,